So from here on out, we're on the record, folks. And we are talking about, again, a little introduction for those of you who have just joined us to the DM32 gauge, something that we call a smart gauge simply because it's so similar to a smartphone. And let me explain to you why. We are recording. So these are some of the things that we're going to be talking about today. Again, very basic, very introductory, but very, I want to say functional. So really sort of how to get started, how to have a hands-on. And I think that in the future, especially if you reference this video, you'll be able to find a lot about some of your questions, basic questions about how to work it. And you can actually point people to that have questions for you, sort of, oh, I'm using a DM32, how do I use the ports and connections, very simply how they work, why they're different. I know that we have a bunch of people that said that they are using the DG700, so let me explain why. Simple things, little design features like the ports and the connections are so much different. I want to emphasize the importance of updating your firmware. It's going to be very important, something that we've talked about probably twice already, and I'm going to continue to talk about it because it is crucial. We're going to talk a little bit about the interface and operation, and that's kind of where we get the idea or the concept or the terminology, the philosophy that that this is a smart gauge, although I do not believe that is, I believe that is trademarked to another piece of equipment, so I'm using it only as my own personal opinion. How it calculates results, how you can get plenty of results. Talk about some of the common errors that people run into that you can easily avoid with a little bit of forethought. We'll talk about how it can run other manufacturers' fans, and that's specifically the Energy Conservatory, and maybe running other devices and whole flow. So that's something that we'll get to at the end if we have time. And if any more questions, anything that you guys would like me to emphasize more, please use the question panel. So let's move on. Let's get started a little bit of history, folks. The past, the present, the future. Of course, we all know if you're into Eastern philosophy, there's no different. But in '89, this is what a duct tester looked like. In 1990, it started to change to what Colin Gensch had a concept that he wanted to basically make the gauge into a computer. He wanted it not just to take readings, but he wanted it also to control the test. So you'll see as at about 1998, it actually was the first move to the digital gauge, which left behind these the more standard or the more analog pressure gauges. And now since 2013, we've released the DM32, the one that we're going to talk about today. Any questions about that? All right. So first, let's start. I want to start with a little bit of discussion. I know that many of you said that you're actually using a DM32 with Wi-Fi. But I want to talk a little bit just about the DM32 as it arrives in your mailbox or at the work site, and you know, what it has before you actually institute the Wi-Fi. So it does convert results in a gauge. This is something that you will not find in other gauges in respect that you can actually do ACH at 50 or whatever test you want to do at. You do not have to take any of the readings outside of the gauge and convert it. We're going to talk a little bit more about that. It is a visual display, so this is exactly what you'll see when you're actually looking at a DM32. It is a touch screen. It tests at almost any pressure. That means you don't have to set it to test at 25 or at 50 or at 75. You can turn it up to any pressure you want, 71, 61, within, you know, obviously within range of what this gauge can actually do, you know, and what pressure you can actually get the house to. I should make that clear. So it does keep the last setting. That means that whatever you have this set up to do, especially if you're using a Wi-Fi gauge, as many of you mentioned, and you have it already set up to automatically jump onto a network or automatically create a network, then when you turn it back on, it'll have the same settings. So this guy, right before he turned this off, he was running a Minneapolis fan. And he was doing ACH at 50, and he did not use he was using the extrapolation, the add feature. And so when he turned that off, 2 days later, he went out to do another test, turned it back on, and his gauge was set to do the same reading. So all he had to do was sort of set it to go to 50, and he was ready to go. So It changes results or units while testing. Let's say that you're actually running a test and you kind of curious not only what the ACH50 is, but what the CFM is. All you have to do is click the button and right here, or I'm sorry, just touch this spot right here, and then you can change the settings and you don't even have to stop the fan. And calibration interval of 5 years. This is really, really important. In fact, I just, last week, I was in Texas at ACI, and I talked to some folks in weatherization, similar to some of the folks, some of you out there, and they had mentioned that they had a DOE visit, and the DOE visit had criticized them for not having their gauges up to date, not having them calibrated up to date, because the gauges they were using, the manufacturer's instructions said that they needed to be calibrated every 2 years. This only needs to be calibrated every 5 years. So that is mathematically, not only is this one of the best gauges, or probably, in my opinion, the best gauge out there, but I think it actually saves you money just on calibration over the course of a few years, right? So, so here's the other gauge. Here's the DG700, and what you're seeing here is basically how you can use the DM32 to connect to any energy conservatory fan, or actually any Retrotec fan. So it's pretty simple. Using, here you see an energy conservatory blower door and their speed controller, and what you have over here is a speed control adapter. So with that speed control adapter, you're actually able to take your DM32, plug it in at the top using your speed controls cable, goes into this adapter or this fob, and it comes out with this with the 1/8 inch, or the, I believe it's called the stereo input, and then plugs into the speed controller of the energy conservatory fan. So basically, you can get all of the benefits and all of the software, all the free software, everything that comes along with running a DM32, but you don't have to go bonkers buying a completely new system. You can actually use the system you have and then upgrade to this gauge. And as you can see, this is actually a screenshot from a DM32 showing the different types of equipment that you can use. Everything from a duct blaster, all 3 of the Minneapolis fans, an exhaust flow meter, and even a true flow grid. So unless there's any questions, I'm going to move on. And this is, yeah, just want to show you that again. I thought it was pretty cool. So what's more is you can actually trade in your DM32 or your DM2 or your DG700. And for a small price, you can actually upgrade to the DM32 Smart Gauge. So I want to make that clear. I know that there were several folks out there that said that they actually had a DG700. So this is this sale, or this trade-in offer only lasts through this year. But by December, if you want to get some money back for that DG700, you want to upgrade, and like I said, especially considering the calibration, the amount of calibration it needs, actually you save quite a bit of money running this upgraded touchscreen Smart Gauge. And if you have a DM2 and you'd like to trade that in, we'll also give you some money for that. So want to make sure you're all clear with that. Is everybody, how's the pace going? Are we going too fast, too slow, anybody? All right. So here's a little bit, let's get into the ports, sort of the basic setup. So first of all, I want to let you know that just like any or all 3 of the major gauges, or the most well-known digital gauges on the market, there are 2 channels. There's a channel A and a channel B. And what you see up here is the top view of the screen sort of folded back. I'm sorry, of the, not of the screen, I apologize, of the gauge itself, folded back so that you can actually see both the screen, the front view, and the top view. And that shows us both channel A and channel B. And here are the physical connections, and here are the digital connections. So I want to talk a little bit about that. But I think well, actually I want to, so let's do this. Let's break it up. Let's separate it and get a little bit more in depth into the difference between channel A and channel B. As you can see, these 2 gauges are, it's essentially a single gauge that has 2 pressure manometers, 2 differential gauges that are connected only by a battery. And that is extremely important to note, because a little bit later I will explain to you about how you can test both of these gauges by referencing them against each other. So that single gauge, you can use both channels, which are essentially two different manometers. So before we go any further, I want to talk a little bit, and I think it's extremely important to talk about what a manometer is. It's a differential pressure gauge. So the manometer measures the pressure difference between two locations, and that is so important for people to understand, because frequently I talk to people who are very savvy, who can run tests, or great at running tests, and have been doing it for a long time, but actually never really understood or never really fundamentally grasped the idea that what they're seeing, the results that they're given, are just the difference between 2 points. Okay, so that's comparing an input location to a reference location. But it's not an absolute pressure. Absolute pressures like feet, or like Fahrenheit or Celsius, which basically means that no matter where you are, you're still 2 meters tall, and it's still 24 degrees Celsius, no matter what. That's different here, because what we're talking about now is that you could be with reference to the reference, or the difference between 2 points, makes all the difference when we're talking about differential pressures. Make sense to everybody? And how are we going? Is this too basic, too simple? Okay. So yeah, the idea that put the reference, let's talk a little bit about the reference. Here you have, again, me, yours truly, out here just placing a reference tube. And why is that important? Because, well, one of the most important things, and this is drawing from my experience working in a very, very busy weatherization company in Chicago. We did thousands, in fact, over 2 years we did 22,000 retrofits. And what I saw time and time again was this disparity between the test in blower doors and the interim test on the blower doors, and then the test out blower doors. And what we found when we started trying to figure out what the difference was it wasn't the way that people, wasn't the level of expertise. It was actually oftentimes where they put their reference tubing. So the reference tubing is always going to be the starting measurement, and that's very important to understand. It's always, since it's always a starting point, it's always 0. So this tube right here, the reading that I'm getting off of this tube is 0, and that's going to be whatever it was in reference to that, that's its starting point. So whether the pressure outside is 2,000 or whatever the, in terms of pascals, whatever that atmospheric pressure is outside, it doesn't make any difference, because it's, according to this tube, it's 0. So whatever the reference to, whatever the pressure in the inside to the outside, the difference between those two. So if the pressure outside is, and I'm going to make up a number, 3,000 pascals, if in reference to the inside of the house, which is 3,050 pascals, the reading that I will get on my gauge is 50 pascals. And if that doesn't make sense, I apologize. I will explain a little bit further. So let's look at let's take 3 cups of water. One is cold, one is warm, and one is hot. So if we use a differential warmth perspective to explain differential pressure, it would look a little something like this. So let's say that we used cold is 0. So that's our reference, right? So that would mean warm is plus 25 if we were using the input on warm, and hot would be plus 75. So again, the difference, it's again, what we're seeing is the difference between these two, and it is communicated in a number. And so does that make sense to everybody? If so, then let me ask you this question. Now, if we take the reference and we change the reference, let's change the reference to the warm water. So now, if the reference is the warm water, the warm water is 0. If cold's negative 25, then hot is plus 50. So you see how that changes? The last example, we had the cold water as the reference, and it was 0. Then, the warm water was 25, hot water was 75. But then when we changed the reference to the warm water, we had a negative 25 for cold and a positive 50 for hot. So I want to ask you a question. Please use your question panel to answer this question. What do you think the numbers for cold and warm would be if we changed the reference to the hot water? what would the numbers be? Please use your question panel to type in the answers. We got some fast folks out there. That's right. Exactly. As Mr. Mendez said, I think -75 and -50 would probably be the answer, so it's great that you're getting that. And those would be negative because our reference, the hot reference, would be 0. So everything that was less hot would be a negative. Okay, so I'm going to move on. And I want to talk, now that we've kind of talked about what those manometers are, or what those, how we have, or how they work, I can go back to explaining how those channels work. So again, keep in mind that when we talk about a channel, we're literally talking about separate manometers. So with the DM32 Smart Gauge, the channel A, so this is what the channel A, what the input looks like, and the reference, so again, this is always going to be 0. And that is going to be read out on the top of the screen. And then channel B is got, and again, the input on the outside of the gauge and the reference on the inside of the gauge, and that will be found on the second part, or the just underneath channel A. So let's take a look at how those work. So channel A is normally considered pressure or test pressure. Now with channel A, you can make your choice of pressures. You can use inches of water column. You can use Pascal. You can choose even, I think, pounds per square foot, but or pounds per square foot, depending on what you test at. But that's usually the test pressure. With channel B is usually the results, normally the results. And so those results can be anything. It can be pressure, it can be cubic feet per minute, it can be ACH at 50, it can even be CFM per 100 square foot. In fact, there's a whole host of different types of results, and hopefully if we have a little bit of time, I can give you an idea of some of the other results that we can do, like effective leakage. So with reference A, there are, like I said, they're completely separate, completely physically separated. The only thing that these channels have in common is a power source. So channel A is normally a test pressure. If you're, say, doing a duct test, then you would use this blue tube to connect to the ductwork. And then that red port would be open. So you would be testing this port with reference to the inside. Okay, so then that would mean that whatever the difference between the pressure in the duct and the outside, that would give us our reading. Make sense? So with using the same test as an example, here on channel B, we would be looking for pressure inside of the fan, and that would be extrapolated to give us our flow. So here we would actually have the yellow holes, the yellow tube connected to the duct tester, and the green tube connected to the duct tester. And what that does, and that's a little bit different if you're more familiar with the Energy Conservatory fans, the difference here being that we are actually referencing pressures in the fan. So this is referencing pressures in front and in the back of the connection to the ductwork. And that's going to give you a really nice accurate reading. So put those together, and here's what you have. You have this tube connected to channel A, and these two tubes connected to channel B, which is going to give us the pressure in the duct tester, and this is going to give us the differential pressure between this area and inside the ductwork. Hopefully that makes sense. And then the same sort of applies to the blower door, and the blower is a little bit different because here with the blower door, we are actually referencing pressures outside. So you take the red tube and you put it through the red panel, and you put that outside to reference a pressure to the inside, which is usually left open. Unless you have a lot of turbulence in the area, then you can actually connect a tube to this and put it somewhere inside the building that has less turbulence and give you a nice reading. So with the fan, you're only connecting one yellow tube. Difference between the blower door fan and the duct tester fan is that actually this is referencing flows across the nacelle right here. So this is going to be open to the inside. And again, looks pretty simple. You've got your yellow tube, your red tube to your red panel, and your yellow tube to your yellow blower door. Make sense, everybody? All right, good. Let's talk a little bit about the display. So this touchscreen is 3.2. It's 3.2 inches, which is, I think, about 9 or 10 centimeters. And it's been designed to clearly provide instant access to the settings and the test results from this home screen. So this home screen is what I'm showing you. This displays when the gauge is first turned on. So you notice that there's a little bit of difference here, that it's showing you the area that you have. You haven't set it to a pressure, you haven't set it to a speed yet, and then normally here you will also see when the calibration date, when the last calibration date was, and what the firmware you're using. Now if you start to run a test, you'll change the screen, and this is what it looks like during a test. So in this test I am doing a CFM at 100, I'm sorry, CFM per 100 at 25 pascals, and I've set told my gauge to tell the fan, hey, seek 25 pascals, and I'll explain to you how to use that. And then once it does find 25 pascals, channel A will show 25 pascals and my results. Now if I want, I can actually set that to hold. So let's say that I got the reading that I like, and I want to hold on until I can write it down or put it into, or explain it to someone. All I have to do is actually click on this area right here, and it will set it to hold. Make sense? So with channel B, I'm getting my results, right? So on the same row, the device and range, so just below channel B, I'm sorry, is test results. And that used to be known as mode, but now it's just the test results. And this is where you would tap to change the results. So let's say you don't like the results that you're getting, that you want a different one, you just simply click on that. On to the left, you'll see the device and the range. Again, keep in mind that this is a touch screen. So it's very, very easy to say, okay, I am running the 200. I'm not sure if it's a mid or a low, or I say I'm running a 300 fan, and I'm not sure exactly what the number of the range plug is. But all you have to do is look at the range plug, see how it's set up, and then click on this, actually push on that button. And when you do that, you can actually physically change to the range and the device that it looks like. I hope that makes sense. And then by doing that, now you're going to see up here, you'll see fan speed. This is really important, especially when you're trying to make the decision whether or not you need to use a different range. If you're really if you're really running, the fan speeds running really high, usually means that you need to open up to a larger range. That's a good way of just sort of knowing it. You'll also see right above that the time average. So here's what it looks like once I've actually stopped the test, and then you can see kind of where we started at. All right. So it looks like just a little quick review. Oh, and I'm sorry, I missed this one. It's time averaging. So your time average is up here. Now you can go into the settings here, click on this, and change your time average to whatever you want, 5, 10, even up to 30. But right here is where it tells you what your time average is. Hopefully that makes sense to everybody. And I think we talked about changing ranges. So when you do click on the button to change the range, that's what it looks like. And let's go back. So let's say I want to change the range. I click the button and it goes here. So I just basically touch it right here and I say, oh, that's not the range I have. I touch that button and that's me clicking it, and then it brings up that screen, and then I just look at it and say, it looks more like that, and I click it. Oh, I'm sorry, I click it to mid, and then it shows up just like that. So it's fairly simple. Easy to select device. Keep in mind too that you can do this if you want to change the device. Say you're actually now getting ready to run a blower, you go through the same thing. You touch the icon, and then when you change the device, it will ask you to change to the different device and to the different select the different range configuration. And this one I think is always really important, because I can tell you that honestly, I'm sure everybody on this webinar is probably much smarter than me, but having worked with this, with Retrotec equipment and explained it, I still do not have it committed to my memory what the names of these range configurations are. I know how I'm supposed to set them up, but this is great for me. So I just say, they're all open, so it's this one. I don't even know if it's what it's called. Makes it really easy for people too who are just learning to use the gauge or just learning to do testing. So as far as that's concerned, so oh, and I did mention that I was going to show you a little bit more about how to change or some of the other results you can get. So simply just sort of similar to maybe an Android device or on this gauge, you'll always see this back button. That back button is always going to take you all the way back to the home screen. It's kind of an arrow. And then this button right here will help you to toggle through the screens. So it's always very simple. The interface is very easy. There's only sort of one way, or there's only kind of two choices to go. And here you can see that I've actually clicked on the settings, or sorry, I've clicked on the results, and now these are some of the other lists of different results that we can choose from. And I do have a question, what's the latest version of the firmware? I will get to that in a moment, so thank you for asking. Back to setting pressure. So now we've kind of talked about some of the basically how the screen works and how to change and get set up for your test, but let's actually talk about running a test. It's very, very easy. Simple as this. If I want to set pressure, I just hit set pressure. And remember that the gauge is connected directly to your fan. So it isn't like a, it's not like a cruise function. It's actually just a control. It's almost a remote control. Then if I want to set speed, I hit set speed. Now you do have a knob on your fan, regardless of what type of fan you have, whether it be a duct tester of any kind or a blower door of any kind that's made by Retrotec, you always have the option to run it from your fan. But if your speed control cable is connected to the top of the gauge and connected to the fan, you have the option to run it directly from the gauge. So let me show you an example of what it looks like if I actually run one of these tests. So I hit set pressure or set speed. I'm setting speed here. I set it to 44%. So as soon as I hit set pressure, it gives me this dial. I punch in 44%. I hit set. And then when I go back, you'll see that my speed at the top says 44%. So it just so happens in this example, I'm at 50 pascals, but that doesn't necessarily bring you to 50 pascals. So I want to make sure that I explain this because I know oftentimes people ask me, well, what's the difference between setting speed and setting pressure? Well, I want to test at, say, 50 pascal. If I just set pressure and I hit 50 pascal, it goes to 50 pascal. What do I care about speed? Well, here's the difference. When you use set pressure and instead of set speed, like this one set speed. Well, actually, let me know. I'm sorry. Let me back up. Let me explain a little bit about set speed, and then I'm gonna look forward a little bit and explain about set pressure. But here we go. We set it to 44. You can see that it's at 44, and now I can toggle from here. I can say stop. I don't want to say I want to start over, or I can say 44% is not what I want. I want 43, 42. So I can toggle it up and down pretty easily. So back to the explanation of setting pressure though. So the difference between saying, oh, I want to test at 50 and, oh, I want to test at a percentage is this. If there are people walking in and out of the house, or if you have a problem with people opening the doors or windows and you have it set at, say, 50 pascals or 75 pascals, the fan is, or the gauge is going to tell the fan to stay at 50 pascals to maintain it no matter what. So if anybody is, say, stepping on the hose, walking in front of the fan flow, opening up the door, the fan is going to speed up and speed down. It's going to try its very best to maintain 50 pascals. So there are certain times when that's just not feasible, especially, say, for instance, if you are doing some air sealing, doing some blower door guided air sealing, or if you're doing an IR scan, or if you're just walking around and looking for leaks. That's when it's a better idea just to set the fan to run at a certain percentage of speed, and that way, no matter what, if anybody walks in, walks out, or if anything happens, you won't get the fan trying to pull itself out of the doorway and make you look funny. So another feature, if and any more questions, I am getting to your firmware, so thank you so much again for being patient. Another great feature is this. you have this what we call, well, it's an at button, but it can extrapolate what the pressure would be if it was at the pressure you set it to. So if you say I'm seeking pressure of 50 and I can only get up to 45, I can and I click here, this is telling me what that pressure is at 45. But then I click here and it says, well, what would it be if you're at 50? And then you can see this gives me a different result. So that can be very useful in a lot of situations, especially in bigger, leakier houses, or it can also be very helpful if you want to test to a different or stranger pressure. So let's say, I say strange, but so let's say here, as you can see, I was seeking a value of 50, and it gives me the pressure at 50. But let's say that I want to test at a pressure of 60. I can set it to find the pressure of 60. If I hit the at button, it will tell me what the CFM would be at 60. If I was looking for 75, 75. So again, it's a little bit different than what I was explaining, as I was explaining earlier. It's a little bit different from what you would commonly consider a cruise control on a DG700, in that you're not setting the gauges and saying you have to go to 25, 50, or 75, and then the cruise will set at that. What we're saying here is it works the opposite way. Whatever your gauge is telling the fan to run at, whenever I want to extrapolate what the pressure would be at, it is based on whatever I'm seeking. Hope that makes sense. It's cool. Take my word for it. So there you can see. I think we'll go through it. And then as I explained before, it keeps its previous settings. So here I am. I show up at a work site, and I've got my gauge. I turn it on, and it starts out like this, and that's where you can see what the build is and what the serial number is. And then it says, wait a second, I know that you've been running a 1000, and that you like to test from pascals and CFM. Here is my model number, as I've told you before. Here is the version and the build, which is not up to date. This is not the update one. I'm going to show you what that one is. And then this is the calibration date. So one of the issues that we had, the story I told you earlier about some of my friends in weatherization had, was that they actually couldn't figure out what the calibration date was on their gauge. They were not using a DM32 or a DM2. And here it is, just says specifically right on the gauge. Very easy. Just turn it on and it finds out when it was last calibrated. Okay, here is the answer. The updated version, the firmware is 2.4, build 71. B1, and this was updated in December 1st, 2015, so if you've updated it since then it's up to date. So as I said, the firmware is located right on the splash screen, so when you first turn your gauge on, it'll show you right here at the top what the version build is, and what the version is and the build is. That's the firmware, and it also gives your serial number if you want. The bottom left after the startup, or you can look in settings on the in the gauge if you've already got it turned on. So that's how you find out what your build is. So again, I've turned it on, and it says again, it tells me now again what version of firmware it is, and you can see that this is for demonstration purposes, this is not actual build. Or if I want, I can actually go in to the settings. I hit the settings button right here. It takes me into, excuse me, it takes me into, hit the setting button, let's see, yep, there it is. And it's going to take me into this first page, and then I hit this button right here, click it. Takes me to the second page, and then I click it again, and then it takes me to the third page, and that's where I find my version, and this is the updated version. That's also where you can change the language. I don't know if we have any people out there who are Spanish, French, Polish speaking, German speaking. You will find, if you want to change the language, this is where you find it to change the language. So this is how you actually fix that. So I want to make sure that you understand this, because it does seem it's probably not as fast, fun, and sexy as some of the other explanations of what you can do with it, but it is absolutely crucial. So if you are behind on updating your firmware, it can actually cause the gauge to just not be able to work at all. It can cause it to lock up. It can cause it to do all kinds of weird things that can actually really ruin your testing, and can really put a damper on your day, so to speak. So you want to make sure that you know how to update it, and it's very simple. You just download Gauge Configurator to your PC, and then you plug your gauge using a USB cord into the PC, open up Configurator, and you're ready to go. So I'm going to go through this quickly but step by step. So this is what you would see if you go to retrotec.com into the software page or the support page or the product page. Either way, you can find where the software is. So you go into support, and then you go into software, and then you find DM32 Configurator. Click Learn More, and it will take you to the screen. Click Download, and then you will download it to your PC. When you open it, it looks like this. So you plug your DM32 into it. It says that it's updating. You say OK. Go ahead and update it, and then what will happen is it'll start to update, run that update, and it'll update your firmware. What you can also do, and I do this a lot because I use all my gauges. I bring them to training, I bring them to shows, and I bring them to actually test building houses. So I use a lot of different networks, and it makes it very, very easy to set up the networks using this network button here. So I want to go back one slide so I can explain to you that when I downloaded it, what I was talking about updating the firmware, here's my little firmware button here. If I want to change the network settings, I go here. This makes it much easier. You can change your network settings to make your Wi-Fi gauge join a network, to create its own network, or you want to use an actual hard line in there. You can change all that on the gauge, but if you're typing in a network, or if you need to make it a secure network, this is the best way, the easiest, fastest way to do it. And then there's all the settings. So if you're having any problem with your touch screen, and keep in mind that touch screen, it's not it's actually a pressure screen. The reason why that was designed like that was in case you have gloves on, or dirty hands, or any of that type of stuff, or wet hands if you're sweaty, crawling around in the garage. It won't make that screen act funny. But yeah, if you want to fix any of those, or if you want to change your non-Wi-Fi to a Wi-Fi, you'll actually buy a Wi-Fi code from Retrotec and put it in here, and then that will unlock the Wi-Fi. All right. So we've got a few minutes here, and I'd kind of like to finish up, if it's okay with you guys, to talk a little bit more about what you can do with your Wi-Fi gauge. So one thing that it has to be made clear, and I'm sure that most of you already know this, but something that I always kind of want to explain is that this Wi-Fi gauge, there's a difference between Wi-Fi and Internet. Okay, Wi-Fi is similar to Bluetooth. It is a connection between devices, it is a way of connecting or networking devices that can be created or joined using a Wi-Fi gauge. However, it does not necessarily mean it is a connection to the internet. That is something different. So I want to make sure that's clear. Is that clear to everybody out there? Let me know what you think. So the DM32 itself can only connect to one device at a time. However, you can have several different types of devices or you can have several different DM32s connected to one device, and I'll explain to you how you do that. So you can connect it via the Ethernet. What I say Ethernet, I don't know if that's the way to say it. Some people say Ethernet cord. You can connect it via a USB input. Or as far as hard connections. So the pros and cons are that the Ethernet basically has sort of an unlimited amount of gauges. You have about 100 meters, or about 325 feet, that you can actually use just one Ethernet cord without using some kind of powered repeater or some kind of powered connection. But if you do, that's unlimited. And then the USB is actually limited by about 15 feet, and you can only connect about 5 at a time if you're using a hub. So hopefully that makes sense to folks. And it does connect. It is different. Oh, I want to make sure that everybody knows that the Ethernet, the connection actually connects at the bottom. This connection at the top, and you'll see it says control, that's where your speed control cable connects. So please don't feel bad if you've done this before, because believe me, I talk to a lot of people who have done that, who have accidentally either plugged their speed control cable into the bottom, which is their network connector, right, which you see right there actually says network, or have connected their network connection into the speed control connector. So don't feel ashamed. So I want to talk a little bit now about how you can, or some of the other connections or some of the other things that you can use, the other apps that you can use with a Wi-Fi gauge or a non-Wi-Fi gauge in this particular instance, and what you need to connect. So Gauge Remote. Gauge Remote is a mobile app that you can use on your iOS or Android device, and it connects directly to one gauge via Wi-Fi. Virtual Gauge is a PC piece of software. It can connect to as many gauges as you want, as you like, via an Ethernet, USB, or Wi-Fi connection. And I should say USB is limited to about 5 connections. Configurator, which we just talked about, is a PC piece of software that connects only via USB to a gauge. Data Logger is another PC app that it can connect to your gauge via Ethernet, USB, or Wi-Fi. And I believe this can connect, I know that it can connect to multiple gauges. I'm not sure of the limit. And then Fantastic can connect depending on your license. There are a variety of licenses for Fantastic that can connect anywhere from 1 fan or 1 gauge up to, I believe, 24. So that is a PC piece of that's a PC software, and it can connect Ethernet, USB, or Wi-Fi. And as many of you know, and if you don't know, I'm proud to tell you, be the first one to let you know that rCloud is in the beta release. However, it is public. It is down. You can download it from the Microsoft Store, and you can connect to your gauges, and I'll run a cloud-based test that can work even without an internet connection. But you can run a cloud-based test using a mobile device, and we will have Android and iOS out soon. But right now, it is you can connect via Wi-Fi using a Windows computer or mobile device, but not a phone, and that's pretty cool. I've been doing quite a bit of that recently, and it's really hot stuff. So if you want to know more, there is a quick guide, as I explained earlier. Any of this stuff, if you're looking to do any of this stuff, even say, for instance, figure out how to use a router with a gauge remote and virtual gauge instead of connecting directly, there's a quick guide for it. If you want to find out how to use virtual gauge, there's a quick guide for it. So there's a quick guide for all that. And again, all you have to do is go to Retrotec, go into support, check out manuals and guides, click on the quick guide, and just say DM32 digital Wi-Fi gauge. And that'll show you all the different quick guides for that. So how is that useful? Well, you can use it to share your results if you're doing, say, training. I can provide support both in a classroom using a virtual gauge experience to, say, connect to a gauge that's reading pressures in a small area, and I have a lot of people who couldn't see that gauge, so they can all sit down and I can project it onto a screen, or I can ask them to come up and interact with the gauge to perhaps push a button on the screen and change a real live gauge, or even do a simulated gauge. You can use it to share from the field as well. So you can have multiple gauges appear on one screen, so you could have actually multiple people using gauges, and all theirs come up on the screen, and you can do all kinds of great classroom exercises or even field exercises. So what about the guy who's in the field? Well, you can use it to say, if you have a Wi-Fi gauge and an internet and a computer that's connected to the internet, I can share my screen with anyone anywhere in the world and get training support, get QC support. So here we have a guy who's running his blower door test on a house, and he's connected to the Wi-Fi via his he's connected to a internet connection via his computer and his gauge via the Wi-Fi, and he can say, call his boss and say, I don't understand these readings, can you do a screen share and explain it or fix it? So he sends that out, sends a screen, and his boss, who is sitting on the beach, can say, hey, I can help you fix that. So let's talk a little bit about maintenance and upkeep. We have about 5 minutes. We might run a little bit over, but thank you all for sticking around. I really appreciate it. Hope you got a lot out of it. So first of all, I want to talk a little bit about calibration, about the accuracy of Retrotec fans and blower doors. I'm sorry, fans and gauges. So that's a picture of one of our booster chambers, and this is Retrotec's calibration chamber. This is an elliptical nozzle. So I'm going to read from this because this is not my area of expertise, but I do want to explain it to you as best I can. So there is a calibration test that is performed in accordance with ASTM E1258 using Retrotec's test chamber. It's built according to the AMCA standards 2010, and it's located at the Retrotec factory in 1060 East Pole Road in Everson, Washington. So every single gauge, every DM32 that you get is going to be tested against this calibration chamber. The accuracy is assured. It's established by using one of two NIST traceable furnace models. So that's a 550 pressure gauge, and the serial numbers are there for you if you're interested. And it is accurate to plus or minus 0.04% of a reading. So the system flow rates were determined using the test fan gauges shown above. So again, here it is. So point being that even though it is always a good idea to make sure that you are still in calibration, or that you are still doing a field check on your gauge, rest assured that when you get your gauge, it has been calibrated in a chamber that meets the highest standards. So the calibration will be verified in those standards. That basically it's going to be verified at a minimum of 3 flow rates, where 1 is above or within 10% of the maximum operating flow, and 1 is below or within 10% of the minimum flow measured. Right? So, I got those backwards, sorry. But the calibration at each of these 3 flow rates is performed at 3 back pressures, and that's an induced pressure, where 1 calibration point is above or below, as I explained before. So the point being that each one of these pressure points get multiple tests, and when you get your gauge, you will get a calibration certificate. And I have redacted some of the important information here because this is an actual calibration certificate. So it just says that, so you know, all pressure gauges and test fans are calibrated separately. So they're not all at the same time, each one individually, and it must be verified every 4 years. So we've changed that now to 5 years, so I'm sorry, I'll take that back. And if you're in, then you'll see here at the bottom, these are the flow calibrations. That's the information that you need. And it'll tell you a little bit about your calibration, so you get the certificate with every DM32. Oh, question. So Mr. Williams says, is there any way that you can update firmware from an iPad or tablet? There's not. Unfortunately, I do not know of any Windows tablets, unless you're talking about like a Surface, which is sort of a tablet, sort of not, that actually you can connect a outside piece of equipment to it. So the iPad being the same way. You cannot connect your gauge to a mobile device. It has to be connected to a computer, PC or Mac, and if you're using a Mac, then you'll have to use some sort of methodology to run a Windows app, whichever one is your favorite. So that said, even though they do come calibrated, it is always a good idea to do a field check. I like to do a quick one at least once a week on my gauges because it's so important. And to that end, Retrotec has developed a spreadsheet that you can download for free, and the spreadsheet is cut into 2 parts. One part explains your instructions. It tells you what to do, sort of step by step of how to run the test, and then the second part here at the bottom is where you put your information, and then it will actually tell you if it passes or fails, and then you can figure out if one of your tubes is failing or if one of the channels is not correct. So just a real quick test, and it's done something like this. This is the end, or this is the tubing from an umbilical of a duct tester, and we're using the yellow one. We recommend that you use the yellow one when testing, doing the cross port tests, so that you have the same tube on each one. And it's really simple. You basically test sort of every configuration or every possible cross test as you can. So we're testing there, we're testing the inputs, now we're testing the references versus each other cross. Now we're testing one input to one reference. Now we're testing one reference to one input. And the point being, so what we've done is we set both channel A and channel B to read Pascal, so pressure, and then when I put the tube, when I actually insert the tube onto the port at the top, it will create a pressure inside of the tube. And because these two channels, as we remember I explained earlier that these are two separate manometers connected only by a common battery, they should both read the same pressure within about 2%. So here, when I plug this one in and I create a pressure, and this tube is connected to this tube, so these are actually connected. So the pressure in this tube is going to be reported with a difference to the inside, and so will this. So they should be the same. Another thing to make sure is simple things like there's not water in your tubing. Make sure that there's no holes in your tubing. Here's another test that you can do to make sense of that. Here we have this tubing is plugged in to a DM2. Then I've actually clipped off the top to create a pressure inside of it, and then I watch the pressure. So if I have a tube, in fact I could even do it in the way that I mentioned before, but basically where I took some tubing and I've plugged it in, created pressure in it. If that pressure depletes rapidly, then I know that there's a hole in that tube. So, okay. Well, that is going to basically complete it for today. I'm so glad that you joined us. Are there any other questions, anything that anybody wanted to mention before we sign off? Well, thank you so much for joining us. I hope you had a good time. I hope you learned a lot, and I hope that that it was worth your time. Thank you so much, and we will see you soon.